This video will talk about the last topic that we're going to address in this unit, which is graphs of radical functions. So you'll need the last two papers in your packet. The very last one will be your homework, and then the one in front of that is the one that should say Day 8 graphs of radical functions on it, and that's what we'll look at as we go through this video. So as you sketch the graph of this function here, f of x equals the square root of x, the square root of x will be our parent function or our original function, and if you go to your table, you should see some points like 0, 0, 1, 1, 4, 2, 9, 3, and then the rest are off the graph, or if you go to the left of 0, or if you try to look at some of these negative x values, all you will see is errors. So this is a function that is increasing, though very gradually, to the right. So what we're doing today, we'll look at the transformations of this parent function, and we're going to look a lot at domain and range. So what numbers do not appear to be a part of the domain? And when we talk about domain, we're talking about x values. So those would be negative numbers, because you cannot take the square root of a negative number. How is this shown graphically? Well, there is no graph where there are negative x values. And then to state the domain and the range of this function. So the domain, again, those are our x values. So our x values start at 0 and go forever to the right. So that means our domain, our x values are greater than or equal to 0. And then when you talk about range, you're talking about your y values. And in this case, it's a similar situation because the lowest y value we have is right here on our graph. And since our graph rises from there on, although gradually, the y values will also go up forever. So we say the y's will also be greater than or equal to 0. Now, what we're going to talk about in this lesson is instead of using what we call inequality notation, is to get you used to interval notation. And really, it's a lot easier because you don't have to worry about an inequality sign and which way it should face. So, for example, with what we just did with domain and range, with domain, if you think about what we did on a number line, our x value started at 0. So if you think about graphing that on a number line, you would have had a dot or a closed circle at 0 and then shaded to the right. So in interval notation, what that means is we start at 0 and we go forever to infinity in the right-hand direction. Now, the symbols I have, the brackets versus the parentheses. Anytime you would have a less than or equal to, or in this case that we were looking at, a greater than or equal to, you're going to use a bracket. Okay, one or the other, just depending on where the number is. Another way you can think about it is if you were graphing your inequality on a number line, if you would use a closed circle, then you would use a bracket. Our range in this problem is the same, so there's really no need to put that on a number line as well. But if you were to put something on a number line where you would have an open circle, because you would use just plain old less than or just plain old greater than, then you're going to use a set of parentheses. And then anytime you use a positive infinity or a negative infinity, you will also use parentheses. So in the next several examples, we will look through or talk about when to use brackets, when to use parentheses. One thing to note is that when you are using interval notation, again, which is what this is right here, you always put the smaller number or smaller value first, and then the larger number or larger value second. Okay. So on your paper, again, when you use less than equal to, greater than equal to, use brackets. If it's just less than or greater than, you use parentheses. And anytime you have an infinity involved, you use parentheses. So then on your papers, the parent function has been sketched in for you for the next several examples. So I'm just going to outline it a little more clearly. This point here we often call the point of origin, and that can really help you in writing down your domain and range and also stating your transformations or your translations. If you then graph this in your calculator, and you have to make sure x plus 4 is completely under the radical, or if you have an 83 or an old 84, when you get that parentheses after you hit square root, you have to put in the plus 4 that way and close your parentheses. So when you look at that graph, just like other translations, it's been shifted 4 units to the left. So I don't have a whole bunch of points. You could get more, but I'm just going to sketch that in that way. So the translation would be left 4. The domain and the range, I think it's helpful to use a highlighter and to mark those on your X and Y axis. So the point of origin on this graph is the point -4, 0, because it's been shifted to the left 4 units. So my domain starts at -4 and goes to the right forever. Okay, so since -4 is actually a point on that graph, I do have a bracket around that 4. Because if you look at your table, you can actually see that -4 show up. So that graph starts at -4, and then it goes to the right forever. So we say the domain is -4 to infinity, and then we always have a parenthesis around that infinity. When you talk about range, you're talking about y values. Again, so our y values start at 0. You're talking about y's. And they rise forever, although slowly, but they do rise forever. So our range for this example is going to be the same as the range for our original parent function, because the y values didn't change. It was just slid to the left, but it was not slid up or down at all. So my range will be 0 to infinity. Again, 0 because that point is actually on the graph. You can find it in your table. In the next example, again, the parent function has been drawn in for you just so you have something to compare to. And if you then put this function into your calculator, you should see that that graph has been flipped upside down, and it has also been moved up, and it's been moved up 3. So you should have a point at 0, 3. You should have a point at 1, 2. You should have a point at 4, 1. And you can get more points for your graph if you need, but it should look something kind of like that. Our point of origin is the point 0, 3, and that's going to help us some with our domain and range. So with the translation, it has been flipped or reflected across the x-axis, and then it's been shifted up 3 units. So the domain for this function, the domain starts at the x value of 0 and goes forever to the right. So our domain, just like the parent function, will be starting at 0 and going to the right forever. Our range, though, in this one is a little bit different. The y value, the highest y value we have is at 3, and then that graph goes down forever. Although slowly, it does decrease forever. So the range for this one, it's all the way down at negative infinity first, because if you remember, we always put the values in our interval notation in order from smallest to largest. So it will go all the way down at negative infinity, and then it will stop at the highest y value it reaches, and that y value is 3. And since 3 is on the graph, you will have a bracket on that 3. So again, you're just looking at the smallest to the largest x value, and then the smallest to the largest y value. The last one on the front side of your paper has two ways that graph has been shifted or translated. Again, there is your original, and as you put this function into y equals, hopefully you'll see that it has been shifted right 1, then down 3. So each point on the graph has been shifted right 1 and down 3. So my points will look something sort of like that. Actually, that points over a little bit. Okay, so right here, my point of origin is the point 0. I'm sorry, that point of origin is not correct. All right, so the correct graph is on the screen now. I had it was correct the first time with the right 1 down 3. The point of origin for this graph is the point 1, negative 3. So again, that point of origin is going to help us with our domain and our range. Again, domain talks about x values. So on this graph, the x values start at 1 and they go forever to the right. So our domain means our x values start at 1 and they go forever to the right, or they go to infinity. Then when we talk about our range, those are our y values. So our y values start at negative 3 and then they rise forever. But since they start at negative 3, I will have negative 3 as my first number, and they go forever up. So infinity will be my second value in that interval notation. So again, domain, you're looking at x's, range, you're looking at y's. And again, if you notice here, this point of origin, the x value should be in your domain somewhere, and then the y value should be in your range somewhere. So the next video will address the back side of your paper.